All right, didn't even notice. 1.2 linear measurements. This section we're going to start measuring lengths that are straight lines. So pretty basic, nothing too difficult. For example, here we have a picture of a ruler, and I'm going to ask you to find the segment length from one point to the other. This one's super obvious. You can see that it's clearly 2 inches. Even that one's easy to do. Even though it ends at 3, it doesn't mean it's 3 inches because the starting point's at 2. So clearly you can see that that is only 1 inch long. But this next one's going to be the tricky one. There it is. It goes from 0 inches to past 2 inches, but not past 3 inches. So it's somewhere in between 2 and 3. So obviously it's 2 point something. And so what we have to do is figure out what notch that one is. And it looks like if you count really closely, you can count 1, 2, 3, 4, 5, 6. So it looks like it would be 2.6, which makes a lot of sense, but that is not the answer. Because if you count all the notches from 2 all the way to 3, there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's actually 16 spaces in between 2 inch and 3 inches. So the answer we actually want is 2 and 6 over 16. Alright, so that is kind of tricky, and I know that my little monitor is blocking the actual answer, but I want you to reduce, obviously, 6 over 16, so it is going to be 2 and 3 over 8. So 2 and 3/8 of an inch. Alright? Alright, let's study some postulates. The segment addition postulate. So your question might be, what the heck is a postulate? A postulate is just a mathematical rule that does not need to be proven. It's just a statement that is fact and you don't have to prove it. Alright, so here's our first postulate. If B is between A and C, then AB plus BC is equal to AC. Alright, so that's a little bit confusing, but let's go ahead and draw out a picture, and it's actually very, very simple. If there's a point B, and it's between A and C, so let's go ahead and draw A and C. So obviously B is between A and C. Then the segment AB, this piece, if you add it to BC, this piece, then you should get the whole piece. Alright, so the postulate is pretty simple. It's just saying if you have 2 pieces and then you add them together, you get the big piece. It's very simple. Alright, but you have to be careful because we're going to run into this a little bit later on. The word between and the word midpoint are 2 different words. The word between just means that B is somewhere in between A and C. So it doesn't matter where, as long as it's in between A and C. B could be here, B could be here, B could be here, anywhere between. But when we say the word midpoint, which is not what we're doing today, but I just wanted to warn you, when we use the word midpoint, that means that B has to be exactly in the middle. Alright? So midpoint means exactly in the middle. Between means anywhere in between. Alright? Just be careful with those two words. Let's go ahead and do a fairly easy example. The question is, given that t is between m and h, so here's t, and it's between m and h, you have to find mh. You have to find m all the way to h. Alright, so this is pretty easy. MT is 7.3, TH is 10.1, so all you got to do is add them up to get the whole distance. Very simple. Alright, 7.3 plus 10.1 if you want to use your calculator. 17.4. That one's pretty easy to do in your head as well. Alright, not too bad. Let's do a slightly trickier one. Let's see, we have xz is 15.3 and yz is 3.3. So let's go ahead and label our picture this time. xz, careful, xz is the whole length. Okay, and then yz, 15.3, yz is 3.3, that little piece. You have to find the distance from x to y. Most of you guys can figure it out. You just have to subtract 15.3 minus 3.3 and you should get 12. Pretty easy, nothing too tricky. Let's throw in some algebra into this, because you can't do geometry if you don't know your algebra. That's why you had to pass Algebra 1 to get into geometry, especially accelerated geometry. Alright, so let's see. Given that h is between d and r, and then dh is 4x minus 3, hr is 8x minus 9, and then dr is 132. Alright, so none of this is easy until you draw a picture, so it's always a good idea to draw a picture. H is between D and R. Here's H, here's D, here's R. I just randomly put them as long as the H is in between, then that's fine. We're going to go ahead and label DH, 4x minus 3, label HR, 8x minus 9, and then dr is 132, so the whole length is 132. You have to solve for x. So let's set up an algebra problem. 4x minus 3, if you add it to 8x minus 9, you should get 132. So that whole thing is 132. Add the two pieces together to get the whole thing. Segment, addition, postulate. Use your algebra skills. Combine like terms. Simplify. Add 12 to both sides. And then, of course, divide both sides by 12. And we have x is equal to 12. Super easy still. Alright, our last slide for the day, congruency. Congruency is just shapes that are exactly the same. All the sides match up, all the angles match up. So we're going to decide if two segments are congruent if and only if they are marked congruent. Just so you know, the IFF is not misspelled. It just means if and only if. Alright, so if you have two shapes, they are only congruent if they are marked congruent. For example, well, we have one shape here. It's a pentagon, and they're going to ask you which segments are congruent. Alright, as you can see, PA and NT are the only twos that have that little red dash which means that they are congruent. They are marked equal, and so they are congruent. All right, even though PE looks the same as EN, but because they are not marked, then they are not congruent. So again, you can only say that they are congruent if they are marked. Here's another one. Which segments are congruent? So another way to mark it is by just labeling how long they are. That's also a different form of marking. Notice TR is marked 12 units, and then AN is marked 12 units. Okay? So because they are marked the same, then TR is congruent to AN. Okay? Alright, so that's all we have for today. Not too bad. Go ahead and get started on your homework.